Good morning, everyone. I'd like to present today's agenda. I've been, granted the privilege to be able to tell you what we've got going on today. And really today we've broken down sessions between three guys that are doing delivery. There's myself and a couple more at the back that are doing a very good job at hiding. So we've got the registration process we've already gone through, the introduction from Chris, and this is our first session, Azure and Data Services. How good is that? It's only 45 minutes, at which point we'll take a break, a nice convenient time for a convenience break, and I will hand over to one of my colleagues, Jamie Maguire, who is going to do a session on AI and cognitive services. We'll then have break. We'll revert back to myself for another 45 minutes if you can stomach it, and we'll push on through to the last session, which is Business Intelligence and Power BI by Paul Henwood, who is also with us today. So, who am I? My name is Danail Dimitrov. I'm a Cloud Solutions Architect at Grey Matter, and I work for our technical department, which Chris kindly pointed out before he ran away. So I am going to be delivering the first session today, which is essentially going to be an introduction to Azure. It's going to even the playing field for everybody that hasn't seen Azure maybe to the same level as some of the other people in the room. And we're going to talk about data specifically, because data is the driving focus of today's session. We've tried to break down today's session into three categories. So we've got data, we've got AI, and we've got BI. So I will be covering the data piece. Jamie will be covering the AI and cognitive services side of things, and Paul is going to be covering the business intelligence. So there should be a nice smooth transition, a complete picture, and we'll try and piece those sessions into one another as much as we can to try and have that fluid data flow from beginning to end. So this session is going to start off with the Azure introduction. We're going to talk about SQL Server and some of the SQL offerings on Azure, because relational databases make up a large proportion of our clientele's data store. We're going to be talking about some of the platform services that are natively available in Azure, and we're going to talk about migrating workloads. So in my first session, I'm going to tell hopefully all of you how we can migrate our existing data onto Azure. Jamie's session is going to actually look at how we can start pulling out some new data into our Azure environment from other sources as well. And that should be quite a complete picture. We'll try and wrap up with a Q&A if we've got time, so there will be some microphones floating about at the end of the session for you to ask any questions, and that kind of allows us to stick to the timing of today's session. So, why Azure? Well, we are a gold certified partner, so we're kind of inclined to do something with Azure. We are platform agnostic, so we deal with other platforms as well, like AWS, but we are primarily Microsoft focused. We're founded by the 13th employee of Microsoft, so we are quite driven towards Microsoft technologies. But it's also because Azure is such a good platform. It's my platform of choice, and it's got such good coverage. So with Azure, we've got coverage across 54 regions that cover 140 different countries. So you can access the Azure services from global scale, essentially. And that could be your applications as well. We've got newly announced regions in Norway as well, and Microsoft keep adding new regions and new data centers to carry on improving that infrastructure that's in place for us, which is also already so great. Now, this is going to seem like a bit of a sales slide, but there is a couple of these at the beginning. So with Azure, we've got great sense of global presence, and we're able to geo-replicate all of our data across the globe to improve the performance for all of our customers and how they access that data. We have backups. So with services like Azure SQL Server, which we're going to be looking at, we've got any point in time recovery backups for 35 days, and we can extend that to another 10 years. It's not any point in time, but it is just conventional backups for up to 10 years with daily backups after that. We've got excellent SLAs. So platform services will often have 99.95% uptime or availability. Virtual machines, if they run on premium disks, will have 99.9% availability. If they are in availability sets, it will be 99.95, and if they are in availability zones, it's 99.99, and that is very good availability, guaranteed out of the box by Microsoft. You get excellent support through partners such as ourselves, so we are a cloud solutions provider for Microsoft, which essentially means we can provide break-fix support that doesn't cost anybody anything. So why not take advantage of it? And anything that's hosted on the Azure platform is backed up by Azure Active Directory. So you've got a great identity service that essentially can underpin all of your systems and your whole environment. It could help you control who can navigate what services, what they can provision, and it can actually help you collaborate with other businesses through services like Azure B2B, business to business, or business to consumer, which is native functionality available in Azure Active Directory. We've also got really good scaling. So with a lot of the services that are natively available on the platform, we can horizontally scale or we can vertically scale. Take web apps, for instance. With web apps, they're provisioned off the back of app service plans. With those app service plans, we can actually increase our instances, so horizontally scale. The service will, as well as horizontally scale the resources that are available to ourselves, automatically load balance across those services. So there's no work for us to do at all. Your database services, which we'll talk a little bit about later, can also scale up and down. You can kind of horizontally scale because you can create read-only replicas that other people can access. So you can actually offload some of those read operations as well to improve performance across the environment. And you could do that across all 54 regions that we talked about earlier. You've got some great load balancing mechanisms. So from infrastructure perspective, you've got level 4 conventional load balancers. You've got your level 7 load balancers, which are application gateways. So those are application aware, and you could do things like URL-based routing, SSL offloading, which is really good. And we've also got global load distribution through services like Traffic Manager or Azure Front Door, which is a really good service. So there is really a lot of functionality we can play with on the Azure platform. Now, there is a number of ways we can, access these services. So natively from the platform, we've got the Azure Resource Manager, which is the portal we're going to be using throughout today's demos, or at least mine anyway, which is the replacement for the old ASM portal, back when Azure was Azure Service Manager portal. We've got PowerShell, we've got Azure CLI, we've got APIs and SDKs to access these services, and there's loads of other tools out there which are platform-specific tools for example, your databases and your storage, of which we'll cover some later as well. But before I dive into any demos on any of the fun stuff, I just want to mention a few core concepts. One of those is resource groups. So how many of you have actually provisioned anything into Azure? Put your hands up. Oh, great. So at least I'm not teaching grandma to suck eggs, so that's kind of good. So with Azure, essentially, every single time you provision something, you have to provision it into a resource group. A resource group is not a resource as such. It's kind of like a logical grouping of those resources. The idea then is when you come to deprovision those resources, you don't have to go through and deprovision each one. You could just deprovision the whole resource group, which could be an entire environment. It could be like a staging environment for an application. And that way you know you've got a nice clean slate. But it's essentially a good way to manage billing and a good way to split down your environment into smaller subsystems. You've also got role-based access control. So role-based access control is essentially the way in which you control access to different resources. So you define roles, you give those roles access to the resources. That could be individual resources, that could be whole subscriptions, or resource groupings of resources. And you can delegate, you can put people into those roles that you've defined then to therefore give them access. So those are a few fundamental elements I wanted to talk about and concepts. Then we have the balance of responsibility. So if you go to any cloud workshop or event where there is a presentation, you probably have some form of depiction that looks a bit like this. And that is the balance of responsibility. So if we take a look at the very left-hand side, if we take on-premise infrastructure, it is our responsibility to take care of everything. We have to worry about our networking, how our switches speeds together, what our hypervisors are doing, so that we can then begin to manage our virtual machines and all of the workloads on top of that. And that is a lot of unnecessary work. We then have to think about cooling, electricity, disaster recovery, and all of those other things that you don't simply need to worry about when you think about the cloud. So in the first instance, we've got IaaS. If we take IaaS actually stands for Infrastructure as a Service. So an infrastructure as a service is a virtual machine with your workloads. So it's a very good place to start on the cloud, because essentially what you could do is you could do a lift and shift. So you can take your existing virtual machines that you have on-premise, and that is a good starting place to go into when moving onto the cloud. But that still means that you have to manage everything from the operating system and upwards. So you still have to worry about your Windows updates. You still have to worry about updating any of the software on top of that underpins your business logic. And as people that really want to focus on business logic, we probably don't want to be wasting that much time managing our environment. And that is when you've got platform as a service. So in an infrastructure as a service scenario, if we take a SQL database, to make a SQL database possible and accessible to all of us, what we have to define in scope of an Azure environment is a virtual network. We have to define a certain element of security on that virtual network, so we would define network security groups. We would then have to provision the virtual machine on top of that. We would have to install the SQL Server, and then we would have to provision the database on top. And that effectively means that you're paying for at least 4 different things right there. So you're paying for the virtual machine uptime, any single time, or any moment in time that that server is up and running, you're paying for that computational cost, because you're essentially paying for that to crunch in the background, regardless of whether you're using it or not. You're having to pay for the underlying storage. That would be separate as well. So you would provision your conventional disks. You could provision a terabytes disk, only use 250 gigs of it, but you're still paying for the whole thing. You're also paying for a Windows license, and Windows licensing is not cheap. And even if you've got hybrid benefits to take advantage of the fact you've got existing licenses on-premise, you're still going to be paying a certain element of that license. And on top of that, you have to pay for a SQL Server license. So unless you're using SQL Server Web or Express Edition, so you're using a proper fully fledged standard edition of SQL Server, or Enterprise, you would be paying a hefty SQL Server license as well, and that's all just for one database. If we take Platform as a Service, however, and we'll take a look at a few offerings, it's a lot simpler to provision for it in the first instance, and we don't have to pay for anything. In terms of licensing, you are paying for ongoing computational charges, but those ongoing computational charges are significantly lower. So that is where Azure SQL Database comes into it. So has anybody heard of Azure SQL Database? Okay, a few of us. That's a good start. It's a big improvement over nobody provisioning anything in Azure. So Azure SQL Database has got a lot of benefits. It learns and adapts. So what that essentially means is it constantly monitors the executions on your Azure SQL Server, and it will try and create indexes and drop indexes to improve the performance of your operations, regardless of whether those are read operations or write operations, and what the split between those is. So it will natively pick out any of the queries that you have executing across your databases that are taking a long time to execute, and it will do that straight out of the box without paying a single dime for it. It also scales on the fly. So we can scale proactively or reactively. So reactive scaling, for instance, we can monitor the performance of the database. When that starts to exceed the limits of the resources that we've provisioned against it, we can trigger essentially an alert and cause that database to scale up. Or we can scale reactively. So if we know that between the hours of 9 to 5, Monday to Friday, we're expecting users to log in because those are our usual hours of work, we can simply deploy a schedule and tell it to scale up at 9 o'clock in the morning, scale back down at 5 o'clock in the afternoon. And that scale operation is completely non-intrusive. So essentially what Azure does is it spins up a whole new database in the background of the new size, it copies the data across, it mirrors any of the new transactions, and once both of them are in line, it essentially decommissions the old database and spins up the new one seamlessly. So you experience maybe a millisecond or 2 downtime, which is a blip and doesn't typically impact any of the performance of the users. We've also got a geo-replication that I mentioned earlier. So you've got SQL data sync, so you can have other copies in other geographical locations and have the new transactions synchronized to those other copies, and you get the same essentially flexibility and access to those resources, which is good. So tools like SQL Server Management Studio, Visual Studio, tools that we're already accustomed to using, Those tools just work out the box with those services. Fundamentally, nothing's changed because Azure SQL Database is actually based on the same engine, essentially, that underpins your conventional SQL servers. From a security perspective, we also have encryption out of the box. So all of the data is encrypted at rest on the service. And we've got the notion of service endpoints. So with Azure SQL Server, or Azure SQL Database that is provisioned in Azure SQL Server, essentially any of those instances of that server are going to have a public endpoint that you can navigate to out of the box. But if you didn't want your SQL Server to be accessible, for one, there's the firewall that fronts it, so you can block all of the traffic. But two, you can leverage what we call service endpoints, which gives the SQL Server instance an internal IP address on one of your VNets, and then it basically removes the public endpoint so nobody can see that externally as well. So there's a lot of security elements that we can play with just out of the box. With Azure SQL Database, there's two purchasing models. You've got the original model, which is the DTUs, and you've got the vCore model. So DTUs, a depiction of that is actually that image, are data transactor units which were introduced by Microsoft, and it's a combination metrics of CPU, memory, and disk read and write performance. So essentially, every single time you scale up your DTUs, say for example from 50 to 100, you can expect all of those things to improve. And there is about a correlation between them that it kind of maintains. It's very good for initial databases because a basic tier, which starts with 5 DTUs, costs you something in the region of £3 per month, which we can all agree is quite reasonable for one database, especially when we have to refer back to that previous scenario of paying for a server, license, licenses, and the rest as well. The problem with the DTU model is that you do not get any choice of how many cores you have provisioned. That is pretty much dictated and hard-coded. So unless you use an S3 or above, you are limited to one core. So if you wanted simultaneous transactions and you wanted those to execute at the same time, then you would have to use an S3 tier or above. And even then, that starts with 2 cores, and I don't actually remember at what point it goes beyond that later down the line. And your storage is quite severely limited based on the DTUs. So if you had a database that was over 250 gig, for example, you may see a scenario where you have to increase the DTUs just so you can increase the size of the database to accommodate all of your data. So that's a few factors to be mindful of. And that's when the vCore model comes into play. So the vCore model comes in 2 generations. We've got generation 4 and we've got generation 5. Generation 5 has got larger limits and restrictions, and there's a slight difference between both of them. There is a couple of tables which we'll drill into in a bit as well. And that is that with the vCore model, you essentially pick how many virtual cores you want. Makes sense based on the name. And the storage is completely independent on that. So you can scale up a very large database without having to actually scale up the computation that backs up your database. There is a correlation difference between CPU and RAM in both generations. So in Gen 4, for each 1 virtual core that you have 7 gigabytes of RAM in your database instance. And in generation 5, it's 1 to 5.1, which is a bit of an odd number. So you get slightly less RAM per vCore with generation 5. So there's a few areas to think about. If we take a look at the DTU model, you've got 3 separate tiers that come with the DTU model, and there's a few elements to take into account. So with the basic tier, for example, you're limited to 5 DTUs. That limit increases. You then have the standard tier, which is on standard storage, and you've got premium, and premium is actually on SSD storage, so it's on fast storage. So the disk IOPS is going to change depending on which tier you start with. Your out of the box anytime endpoint recovery changes as well. So if we look at the basic tier, that's 7 days. If we look at standard and premium, that goes up to 35 days. So those are a few areas to consider when changing from one to the other. And then you have the vCore models. So with the vCore models, it looks a little bit more complicated. So you've got your standard, you've got your hyperscale, and you've got your business critical tiers there. The main factors to take into account really is the disk performance. So to give you an idea, on the generation 4 and the generation 5 standard, disk IOPS is 7,000. If we go to business critical, Sorry, if we go to Hyperscale, that can go up to 200,000 IOPS, sorry, so that's significantly larger. The 35 days point in time retention stays the same, and there is varying different core limits as well. So I did say previously, Generation 5 can actually scale a bit more than Generation 4 can. So the Hyperscale, just to quickly touch on that because it was mentioned, is kind of a new tier, relatively new tier compared to the rest of them. And what Microsoft have done with the Hyperscale tiers is completely, I guess, decouple the nodes that are doing the computation from the nodes that are doing the storage element of things. And what that allows us to do is, one, improve performance, but two, improve scalability. So with Generation 4, if I can go back, Generation 4 business critical tiers, we have a 1 terabyte database limit. With Generation 5, we've got a 4 terabyte database size limit. But with Hyperscale, we've got a 100 terabyte size limit. So that is really a lot bigger of a scale and completely exceeds any other cloud database offerings that we know and use at the moment. Because we have decoupled, or Microsoft have decoupled, not to brand myself as Microsoft, the storage from the compute, essentially backup operations no longer impact our performance. So we can back up at any time without actually impacting the live performance of the database. Scaling as well becomes a lot quicker because essentially at the present what you're having to do is every single time you scale up the database, you're having to wait for all of the data in our database to copy across to the new nodes before they can assume ownership of the database moving forwards. Now if you've got a 250 gig database, that's going to take a bit of time. If you've got a terabytes database, that's going to take even longer. But with decoupled storage, that doesn't come in, it essentially doesn't come into play. So we can scale without actually taking into account how big our database is or without even worrying about it. And then you have the notion of elastic pools. Has anybody heard of elastic pools before? So many people have heard of Azure SQL, but elastic pools tends to be a bit less well known. So elastic pools is a very good way of delegating a pool of resources across multiple databases. So take, for instance, we have 5 customers. All of those 5 customers are based in the UK, so they operate at the same time. This is a good scenario for elastic pools. So those customers' workloads would peak and trough at different times, but their hours of operation would be exactly the same. So we would expect their workloads to be between 9 and 5 exactly at the same time. And essentially what we can do is, instead of provision a lot of resources to cater for the peaks of each individual database, we can provision a large pool of resources that all of those databases could share. And if done correctly, we can save them a lot of cost and improve the performance for our customers in doing so. So elastic pools is a very good thing to talk about. Now, we're going to dive into a very quick demo because a lot of you have had a look at Azure SQL Database. We probably won't spend too much time on this, but I just wanted to go through the steps of provisioning an Azure SQL Database, an Elastic Pool, and putting that database in the Elastic Pool to demonstrate how we can do that as well. So from the very new portal, which has changed a little bit back, what we've got here is we can click on the plus on the top left hand side if we want to, or we can navigate to Azure SQL Database, and click on the plus on the top left hand side as well, which would essentially do the same thing. And from here I have to define a number of things. So first of all, I have to define the subscription that's going to pay for the resource that I create, and this is going to be the case for any resource you create in your Azure environment. I then have to define the resource group, that logical grouping of resources that we talked about earlier, before I can then define a database. So logically we'll call this event data. Event data, why not? And I have to define a new server. So this is going to be the server that's going to host this and other databases moving forwards. And I'll call this event data as well, and just make sure that that is currently in use. Event data Dan, why not? When we create an Azure SQL Database server, we have to come up with a username and a password, SA is not possible because SA is the account that Microsoft Azure uses to actually manage the account for us. So SA is by default blocked for us. And what we have to do is specify a new username. So I'm going to specify Dimitrov, and I'm going to come up with a secure password. Again, if I was to come up with a security password that didn't conform to convention and was not strictly secure, that would flag up and would not allow me to continue. And then we have all of these regions. So when you provision a resource in Azure, you have to think quite carefully about where you want to provision those resources. And that is for two factors. One, you've got three factors. One, you've got cost. Cost varies from region to region. Cost is not consistent. What you'll probably find is the older a region is, the cheaper the services get because there's a lot more capacity in our data center or data centers. And Microsoft want to encourage people to use the data centers that have more capacity. So naturally, they're going to be cheaper. Whereas new data centers will start off a little more expensive and will over time decline in cost as well, pretty much even in the map with the older data centers.
Sorry, Dan, just a question. So there in terms of UK, there was one you just highlighted there, there's UK West. Is that Western Europe as it's got down on the left-hand side, or is that the UK? I'm thinking about government data. I probably want it stored in the UK rather than abroad. How much can you specify where that data is held?
You can, so if you wanted to store it within the UK, that's a good question. Then if you pick either of the UK regions, that is strictly stored in the UK. The exact location of data centers is never disclosed by Microsoft for security reasons, but both of those reside within the UK. So even post-Brexit, they'll be in the UK. And the good thing there is when you then come to choose your replication with your services, Microsoft utilized what we call region pairings to determine where your secondary region for those replicas is going to be. And UK West is UK South, UK West secondary region is UK South, UK South secondary region is UK West. So when you say later down the line, actually I want to provision my data in a UK data center, I want the data to replicate to a second region in the event that the primary region goes down, so I want to use geo-replication. But at the same time, I want to guarantee that the data will strictly stay in the UK. As long as you use one of the UK data centers, that will remain the case. So you're absolutely fine. EU West, however, is in Ireland. So that's not going to be in, strictly in the UK.
It's actually, the UK West is actually in Swansea, and the UK South is actually in London. So we don't see specifically where, but they actually are there. In terms of the question for the government data, depending on their data, they can actually store it in Europe. So the regulations do state that it is okay. I know there's sometimes a concern from, let's say, a media concern, and therefore they want to use the UK data center, but they are allowed to use the EU ones, and for some purposes they will still do so.
Perfect. Just really conscious of time. I haven't even gone through a third of the presentation. So the other two factors, rightfully, compliance is one we have to consider. Always when we consider where our data is going to be, the second, one of the top three is that we have to think about is compliance, and third is performance. Logically, if we put the data on the other side of the world, access times are going to be greater. We cannot change that. It's science, so that is something you also have to consider when moving data across. And actually, because all of you have seen kind of the creation steps for a database, I'll quickly go through it. So we pick a region. I'm not going to go through to the end. And essentially, we pick the size of that database. We pick the size of that database that we want to provision with initially. And that is on a per database basis. So we've got the traditional DTU models, and we've got the VCOL models on the right-hand side as well that we get to choose. I'm going to use an existing database server that I've created simply because of the interest of time. And I've created my wonderful resource group for today's resources. And in there, or shall I say R, because there's a number of us using it today. In there, I have these resources. So I've got my SQL Server, which is event data. And my SQL Server is currently got 4 databases on it. Now, this SQL Server doesn't have any elastic pools, so for me to create an elastic pool is really quite simple. I go back to the overview blade, of the Azure SQL Server, not the database itself, and I click New Pool, and it's as simple as that. So let's say data event data pool is the name I decide to go for. I'm very cheap because otherwise I'll get told off, and I will provision it as a basic 50 DTU elastic pool, which in the background will just provision on this server. Now, if I click on the deployment in progress, I can actually see how that particular deployment is progressing. And if I have multiple resources as part of that deployment, I will see that further broken down in the deployment details field in here. So hopefully, this will take about 10 seconds. If not, we'll just move on, and you'll have to take my word for it. This would succeed. One thing I didn't provision, however, in the interest of time ahead of the event is that particular, there we go, pool for databases. So if we go back into our event data and we go back into our database server, and from there go into Elastic Pools, we will now see that Elastic Pool in there. And we can navigate to the Elastic Pool and click on Configure to change two elements. One is the pool settings, so that is how big do we actually want our pool to be, and two, what are the databases that are currently going to reside in our pool. So just by clicking Add Database, I get to see my 4 individual databases that already reside on the server. I click Apply, and it's as simple as that. Those databases will now be moved in that pool of resources and be built as a single pool of 50 elastic DTUs as opposed to on an individual basis. I can press Save, and that would apply the changes. And in the same way, I can move databases back out of that elastic pool if I want to as well. Going back into our presentation and moving on swiftly, I want to talk about migration. Excellent. So there's a couple of tools, or there's actually a lot of tools available to us, and there's a very good website, which I've forgotten to put on there, about migration steps of databases. But essentially, if we want to upgrade our database from SQL Server and migrate it across to Azure, we've got the Data Migration Assistant and the Data Experimentation Assistant, which can facilitate us in achieving that. If we were looking to migrate from alternative sources like an Oracle database, then you have the SQL Server Migration Assistant. But I'm going to focus on the Data Migration Assistant as it's the simplest one from all of them. And the Data Migration Assistant, what it does is, in the first instance, it does an assessment. So you can tell it to do just an assessment alone or an assessment with a migration. With that assessment, it will essentially look at my schema of my database and make sure that that particular database is supported on Azure SQL Database or the target platform of choice. If the schema is not supported in any way, shape, or form, the assessment will highlight the areas where we have a problem, a discrepancy, and it will actually try and generate the SQL statements required to alter the schema of the database to align it with the target platform of choice. So essentially, it will do a lot of work for us. Then we can deploy the schema and use the same tool to migrate. And essentially, the migration steps broken down into 2 sections. In the first instance, we migrate the schema, create the shell, and we then migrate the data over the top. So what the Data Migration Assistant looks like is very simple. So I've got a server in my Azure environment. That server I've provisioned, and I'm very determined to show off, as it is a SQL Server 2008, which aligns with a lot of, unfortunately, SQL servers in current day environments, even past support. This SQL Server is provisioned on Azure, and you should all be able to see the server there. And in there, I have a very bog standard database, which I will show now. So if we give it 10 seconds again, if not, we'll move on. And we navigate into the server. We've got this wonderful database that consists of 2 tables and 1 view that collates both of those tables together. So if we do a select top of 1,000, you'll see that it's only got 8 rows, and that is quite intentional. It's not because I've been lazy, it's for performance purposes. We want to get through this quickly. We don't want to be wasting time. So I've got a few rows in there. Now I want to migrate this data to a database which is on Azure. So I can navigate back to my server, and in navigating to the server, I can actually see the server name here. So this is what I would use to actually connect to the server online. And if I go back into my SQL Server Management Studio and open up a new connection, paste that in there and use SQL authentication, I should be able to see all 4 servers that I have access to. Now I'm using the account that I first created the SQL Server with. By default, I will have access to everything. You can actually create subsequent users and limit their access so they can only see a subset of those databases if you wanted to moving forwards. But that is much of a programmatic approach. So in here, I've got my wonderful empty database, which hasn't got any tables or views to prove that is currently empty. And if we fire up the data migration assistant, we'll just showcase exactly how simple this is. So from the left-hand side, we start a new project and we get to do either an assessment or an assessment with a migration. We'll go with an assessment with a migration and call this event data migration for a lack of originality. My source database is going to be a SQL Server, and my target can be actually another SQL Server. It could be a managed instance, but I'm going to stick with plain Azure SQL database, which I'll use for my migration. I want to migrate both the schema and the data, so I'll choose that as the migration scope, and I'll press create. So in the first instance, I have to choose the data, where the data is coming from, the source. So I'm going to do localhost because I can't remember what I named the server, and I'm going to use the account that I've actually logged onto the Windows machine to authenticate the tool. I'm going to choose the source database that I want to migrate and press next to move on to the target. Now with the target, I'm going to migrate to this database. I've actually already done something in the background to make sure that this process is smooth. If I went to press and authenticate now, it will actually tell me that I'm not able to talk to the database. And that is because by default, when you provision an Azure SQL Server, if we go to the firewall on the left-hand side here, if I can see it, firewall and virtual networks, it's actually got an access list, and that access list by default blocks everything. So I would have to whitelist my IP address ahead of time to make sure that I can actually access those databases through SQL Server Management Studio that I've done already, and through the Data Migration Assistant for the purposes of the migration. And now if we navigate back into the tool and type in our password, we should be able to do a very quick migration. We connect and we can choose our empty database as our target. We have to choose what objects we want to migrate from the existing database. So if you wanted to split your migration or break down your database, I guess, into smaller databases which contain different tables from your environment, then essentially you can, with limited scope, do that directly from the Database Migration Assistant. But I'm going to choose all tables and all views for the purposes of the demo. That will then generate the schema to replicate the existing schema onto the Azure SQL Database instance that I can then deploy. And essentially that's created all of the tables for us to deploy our data into, and our views as well. And I will then proceed to select the tables that I want to migrate the data from. So both of these tables have 4 rows each. If I press Start Data Migration, that will essentially migrate the data from the 4 tables, and that is done in 4 seconds. So essentially what we've done very quickly is we've migrated both of those tables, that view, and the data that resides in both of those. But that is all well and good if you want to do an offline migration. What happens if you want to migrate data on the go and you can't afford to take your business offline, wait for 250 gigs of data to migrate across, before you can bring it back up and online again. And essentially Microsoft have provided a service for that as well. So we have the database migration service. And the database migration service comes with 2 different tiers. You've got the standard tier and you've got the premium tier. Standard tier is free, but it will only allow you to do offline migrations as such. So essentially it will facilitate what we just did and help us monitor the progress of that. The premium tier would allow us to do an online migration. And the beauty of the premium tier is that yes, it's a paid-for service, but it's only a paid-for service after the first 183 free days. So if you were looking to migrate, I would time this quite well with the rest of the project to make sure you get the most bang for your buck, or essentially no buck, and use this service to migrate your data across. Now, there is a few setup steps. It requires that all of your databases have been backed up previously. It requires that you have either CDC, change data capture, enabled on your databases, or you have primary keys in all of the tables that you want to migrate the data from. It has to have one or the other to be able to track all of the changes in the database to help facilitate an online migration. And CDC is only available in enterprise and dev versions of SQL Server, or at least that was the case in 2008, if that is the database engine you want to migrate from. So those are a few things to consider. You then have to install the distributor role on the server, which is quite simple, and you're essentially very ready to migrate data across. Now, because we haven't got too much time to go through setting up of a new server, because essentially what it does is it actually provisions underlying VMs that are going to take ownership of that replication process in the background, and that takes a bit of time. It's not a simple platform service that would just take a couple of seconds. I will refer to one I created earlier in true Blue Peter fashion. And we have Azure Database Migration Service. So the Azure Database Migration Service, in there I'm replicating, I've got one project, and in that particular project I'm actually currently replicating one database. So after I've gone through that process and I've set up everything in terms of the replication, I've copied the initial data. Well, you don't actually have to copy the data, but what you have to do is you have to copy the schema across to the target database that you want to migrate to. I let the service take care of all of the initial copying of all of the data, and I let the service take care of any future changes. So if I click on this particular database that's currently ready to cut over, I can see that I've done my original migration. My original migration was of 4 rows of my address table on my customer table. And since then, it's actually made a few incremental changes. So my incremental data sync, which, unless I'm going senile, but any incremental changes would then show up in here as well. And once the server's essentially finished mirroring all of the latest transactions across to the new database, and we're at a point where both databases are in sync, I can then start a cutover process. And with that cutover process, it walks me through a few simple steps of quickly stopping the traffic to the old database server, essentially waiting for any of the new transactions to replicate across, and then I validate my database to make sure that they're both aligned before I basically tell users to point to the new one and use it. So essentially what you've done there is you shrunk what is potentially a very lengthy process, a large window of downtime, to just a few minutes, which I'm sure for most businesses is acceptable. And that is the beauty of the Azure SQL Database Migration Service. So we've just gone through that. And I just want to mention a few other offerings because it's been quite heavy, a heavy focus on Azure SQL Database. And that is, with Azure SQL Database, just like any service, we've got our upsides and we've got our downsides. The upsides is that Azure SQL Database is a heavily abstracted service. And because it's so heavily abstracted, it allows us to scale up in that seamless fashion that we mentioned earlier. But because of that, it has a number of downfalls. So we cannot execute cross-database queries natively on Azure SQL Database. So if we have an application that relies on us joining data on the database side from multiple databases through, for example, views, then that potentially can't migrate into Azure SQL Database unless we rework the application and the way we actually query in the data. It doesn't have any SSIS, SSRS, or SSAS. So that's SQL Server Integration Services, SQL Server Reporting Services, or SQL Server Analysis Services. That functionality is not there, but we'll talk about what we can do to bridge that gap in my second session. But it is, so we don't have a SQL Server agent either. So if you're potentially utilizing that to periodically cleanse your data at the moment or do anything with your data overnight, maybe move that data, that is no longer an option for us as well. So that's another service we have to look to offload to another platform offering on Azure. But it's very cost effective. So that is where we want to be. That is kind of our end goal, and that's where we want to get our data to, really, if possible. Now, if some of those restrictions are a hiccup and they potentially raise a concern for us, then what we've got is we have SQL Server managed instances, which is kind of a halfway point between the SQL Server and Azure SQL Database. So it's essentially a Microsoft managed Azure SQL Server. But instead of paying for individual databases, you pay for the whole server, and you provision resources for the whole server. So you don't need to worry about managing the underlying operating system or upgrading the SQL Server itself. Microsoft do that for you, but you are paying for the whole service. You are paying for a whole managed server, so it costs a little bit more than Azure SQL Database. The good thing is it's got near 100% compatibility. You've got those cross-database queries back, so if you need to execute those, you've got those there as well. You've got your SQL Server agent. So if you've got those nightly runs that need to execute those periodical jobs that are scheduled to run, you can migrate those straight into Azure SQL managed instances. You do have limited control as to how that agent behaves. If you've customized the behavior of your agent at the present, so it doesn't behave like an out-of-the-box SQL Server agent, then that is something you're not going to be able to do moving forwards, but it is a happy medium, so it is, again, a good place to be in the interim at least, as well as a cost-effective solution. And of course, there's always the conventional SQL Server on the VM. Regardless of what I say, some people simply cannot move away from their legacy implementations. The good thing there is, if you were to shift your SQL Server, and your SQL Server is 2008 into Azure, you get 3 years extended support out of the box free of charge. So you're no longer having to pay for that 3 years extended support, which can actually save you a lot of money. So if you need to buy yourself time so that you can restructure your data and utilize some of the more modern platform offerings on the platform, then a lift and shift may be your place to be in the first instance before you can migrate into some of those platform services. So essentially we have three options when we talk about Azure, when we talk about SQL Server, and those are SQL Server in a VM, the next level up is managed instances, and then we have the Azure SQL Database. There's also other offerings for databases on the Azure, reserved instances. Before we move, this is a new slide for me. So reserved instances is something I just quickly want to mention. Has anybody heard of reserved instances and reserved capacity? Okay, not very many people. So I'm going to talk about that just for the benefit of everybody in the room. Now, reserved instances is an upfront 1 year or 3 year commitment. Microsoft recently changed things, so you don't have to pay it in bulk at the beginning. You can pay for it on a pay monthly basis, but commit to it upfront. So if you still want to do the whole pay monthly basis, you can still leverage that with reserved instances. It just means that you've committed ahead of time. And essentially what you can commit for is you can commit for the compute charge of the VM. So I said earlier, in an instance with an Azure SQL database server, you're paying for the compute charge, you're paying for the storage, you're paying for the Windows license, and you're paying for the SQL Server license. With reserved instances, you upfront commit to the compute side of things. So you pay for those cores and RAM basically ahead of time. You can also do upfront commitments for licenses, and you could do that for the Windows Server license as well. So if you didn't have a hybrid benefit and you envisioned yourselves using those Windows licenses for a period of at least 1 year moving forwards, then that may be a potential cost saving for yourselves. And you can also upfront commit for SQL Server as well, for the license. And when you combine these things together, you can essentially reach up to 72% savings of your VM which is a massive saving. I'm sure we'd all agree. But if you happen to be at the cutting edge of things and you're in a position where you can move onto Azure SQL database or managed instances, then you can actually do an upfront commitment of capacity for Azure SQL database as well. That is only possible for the vCore model, but you can do it for single databases and elastic pools as well. So you can do an upfront commitment in the same way for 1 year or 3 years to save on the ongoing running costs. Some other options that are available, and I'm eating into your coffee break, so I do apologize, I'm going to hurry with this bit, is we've got your conventional Azure SQL tables. Azure SQL tables is a non-relational NoSQL store. So if you just wanted to store flat tables of data, it's a very cost-effective way of storing your data on Azure. You've got Cosmos DB, and Cosmos DB is a geoscale solution. It's for non-relational data. So if you had like documents that you wanted to store, Document DB is a perfect scenario for Cosmos DB. And then you have 5 different consistency model tiers as well, so you can manage your consistency between your data in different regions as well, quite granularly. The other 3 offerings that we have on the Azure platform, if these are databases you already have on-premise, is Azure Database for PostgreSQL, MySQL, and MariaDB. And those are very good as well. And I want to reiterate, I actually found this out quite recently, PostgreSQL also supports extensions as well. So if you have PostgreSQL and you have PostGIS on top of that, you can actually install your PostGIS extension on the native platform offering on Azure as well. So there is no excuse as to why we can't migrate more of our data onto the Azure platform. And with that in mind, just because I've left you with about a 10-minute coffee break, what we've covered in today's session has essentially been why Azure. We all agree it's a great platform. Some of the migration tools that I quickly whizzed through, but I can go through those slowly later on if somebody wants to grab me, and some of the platform offerings that are natively available on the service. The next session, which is going to be led by Jamie Maguire after the coffee break, is going, in that session, he's going to look at how we can pull data from other sources into our Azure environment, and how we can apply AI and cognitive services on top of that data to generate even more data from the data we've got. Thank you for listening.